Next, I'd like to introduce you to Dr. Cara Levitch, who works with Stephen Sands in psychiatry and behavioral sciences in pediatrics. And she is going to tell us about balancing the seesaw of pediatric cancer.
Treatment for pediatric cancer is fixed to a seesaw. When you increase the effectiveness of cancer treatment, you cause more toxicity to the brain. And when you try to minimize toxicity, you increase the risk of failed treatment or relapse. But what if we didn't have to give up one for the other? What if we could balance the seesaw and have effective cancer care that's also less toxic to the developing brain? As a pediatric neuropsychologist, I work with many childhood survivors of acute lymphoblastic leukemia, or ALL, the most common type of childhood cancer. Fortunately, more than 90% of children diagnosed with ALL survive, and the field has made progress in reducing the toxicity of cancer treatment. However, cognitive deficits remain prominent after treatment, and they result in worse academic and occupational performance and worse quality of life. These cognitive deficits are a lifelong problem, and there are limited interventions to protect children with ALL against cognitive decline. In addition, we're unable to accurately predict which children are at greatest risk for later cognitive decline. So to increase the accuracy of our predictive model, we need to better understand the biology underlying treatment-induced cognitive decline. And that's where our research is focused. Our preliminary studies have shown that we can use genes and biomarkers to provide insight into the biology of treatment-induced cognitive decline. Specifically, biomarkers of oxidative stress, which cause damage to brain cells, increase throughout the course of chemotherapy. In addition, certain genes can make you more vulnerable to oxidative stress, and they are predictive of the severity of cognitive deficits post-treatment. Further, our analyses reveal two separate groups of children, one with better and one with worse cognitive outcomes. Currently, our research uses an innovative combination of genetic risk factors, biomarkers, repeat computerized testing, and neuropsychological assessment post-treatment to identify children with ALL early on who are at greatest risk for later cognitive decline. And why is this important? Because if we can accurately predict which children are at greatest risk, then we can develop protective interventions for this subgroup, started within the first weeks of chemotherapy, that might prevent or mitigate later cognitive decline. Our hope is that we can finally balance the seesaw of pediatric cancer care and reduce the lasting burdens of curative treatment for childhood survivors of ALL. Thank you.